Welcome back to Fat Mama Physics. Here we have another video on analyzing circuits. The reason why I wanted to go over this one is that this looks different. A lot of my students will say, oh, it looks different than the one we did before. I don't know how to analyze anymore. So, this one we did over here, it's messy now. But basically, you can take a look at how it nicely lays out the fact that these two sets of resistors are parallel with one another. But then this one, in this example, everything is just in boxes. And it's like, I don't know, which one goes first, which ones are in series, which ones are in parallel. Lots of confusion here. So that's why I want to go over this one, because we can draw this in a way to help simplify for you. There you go, I just added another page. So what I'm going to do here is I am going to redraw this circuit so that it looks like the circuits that you've seen before. Or another way just to kind of go through it so you kind of have an idea what's going on here. Whenever you see a circuit and you don't know what's going on and how to simplify it, the easiest way is to trace from where the current begins. The current begins from this battery. The positive terminus, and you can tell it's a positive because it's longer. The side of the battery is longer, the side's negative. So the current comes here, and it goes around, and that's the first junction. So I would do this. I would just draw this, let's draw this battery here, just like the way we did it, just like how the problem did it. And then I'm going to show that junction here to match with the one over there. Then there's a split. So whenever there's a split, I'm going to do this. I'm going to draw it like there's something happening in parallel, okay? So that it looks like stuff that we've seen before, if you want to put it that way. Once there's a split, one of its junctions then goes into this 3 ohm resistor. So I'm going to draw that there. This guy is 3 ohms. This one here at the top here is going to go through this other resistor, which there's a few more data that we have about it. First of all, we know that the potential drop here is 5 volts. We also know that this resistor is 6 ohms. And then this comes around here, which I'm going to draw like that. And it's going to meet up with this guy over here. So that's our junction point again. Now, this question could have made a little bit more trickier for you and put another resistor here. So think about what would that do to our drawing. Hey, guess what? Maybe a good time to pause the video and think. Okay, so if you said that this resistor would go somewhere here, you are correct. But we don't have that case right now, so we can forget about that guy. Let's just do that. Okay, so we're not done yet. Okay, after the 2 wires connect back here, they continue together, and it goes through another resistor over here. So I'm just going to loop my current around, otherwise I'm just going to have a really big big drawing here. So this guy is R. I'm going to call that R. And he comes back to my end, the negative side of my terminus here. And our battery is 18 volts. Okay, so there we go. We've taken a convoluted drawing and simplified it, so it probably will be easier for you to analyze. This is another tactic that you can use when analyzing circuits. Well then, what's the question? The question is, determine the value of resistor R. Oh, there's another question. If the 6 amp light resistor, so that's this guy over here, burned out, what would be the new current across the battery? Oh, okay. That's not too bad, and but maybe something interesting might come out of that discussion. Our first task is to find R, so let's do that first. This seems like a little bit different than the problems we've dealt with before, because usually we would have all the resistors and we need to find the total resistance to find the total current, but not in this case. But I think we have a lot of information already, because notice what's given over here. That tells us a lot. So let's begin first by looking at 5 or the 6 ohms, so 5 volts. And guess what? Since this is 5 volts across this resistor, you know what? I'm just going to use blue for that. since this is 5 volts across that resistor, it's going to be exactly the same potential drop across this other resistor because they're in parallel. And this means that we can figure out the current through this resistor, and we can figure out the current through this resistor because we know both the volts and the ohms. Volts and ohms. So let's solve that here. Okay, so we know that from Ohm's law, I is equal to V over R. I hope I don't have to do the math, how to arrange that anymore. This is 5 volts over 6 ohms, and this is going to give me 5 over 6, which is 0.8333. Okay, so this is, I'm going to keep all my digits, okay, in amps. This guy over here, the current is going to be again 5 volts, but this time is 3 ohms, and this is going to give me 0.16 repeated amps, okay? Hey, guess what? Since we know the current coming here, which is 0.83 amps, and the current coming here, which is 0.16 amps, we can add them together to get the current going across this big resistor here. So let's add those two together. We're going to get 2.5. Very nice number. 2.5 amps. Hey, but that's not the only thing that we know. We know that the total potential drop is 18 volts. We know that 5 volts have been used up over here, okay? Since this is 5 volts and this is the only remaining potential drop, we just have to subtract 5 volts from 18 volts to figure out the potential drop here, in which 18 minus 5 is going to give us a total of 13 volt drop across this resistor. Hey, and to find the resistance, we just have to use Ohm's law. Ohm's law to get resistance is just the opposite of that, which is V over I, and V is 13 volts, the I is 2.5, and we get 13 divided by 2.5, 5.2 amps. Sorry, 5.2 ohms. Yay, we did it. Okay, so that is kind of what we should do there. So notice that this is a little bit different than the analysis steps that we've done before. Before we tend to go big picture. We find the big picture first, but now we kind of start from itsy bitsy detail and then we kind of move our way out. Very interesting. So when you're solving and analyzing circuits, it's like a problem. It's like a puzzle. You can't be stuck on one way, but here, of course, we're just introducing different methods, how we can help you with analyzing circuits. The next question is, if this resistor, which one is that? Let's do purple here. This guy. If this guy burned out, which means it completely disappeared from the circuit, what would be the new current across the battery? This is actually not very hard to solve, because why? We would just get rid of this resistor completely, and this part of the circuit would be destroyed, essentially. We just destroy that part of the circuit. But everything else remains the same. What does remain the same? That's important. So let's redraw this whole thing again, just to make sure that we know what's happening. That resistor that remains is still there, and that's the 3 ohm and the one that we found, 5.21. I forgot. The 3 ohm resistor and the 5.21. Okay, and everything else we just have to connect in series. The battery is still the same, and what do we want to find? We want to find the current across the battery. Well, that's not very hard anymore because this is just 2 resistors in series. And again, we can combine their total resistance which is going to be 8.2 if we add 3 plus 5.2, and we know that the current across the battery, which is just I total, the I total is just equal to the voltage over the total resistance, which is 18 divided by 8.2, and that's going to give us 2.195, or rounded up to 2.2 amps. Okay? I know this was done very messy, but hopefully it's not too hard. And there it is. Okay? So, just to recap this question, please don't be scared by what a diagram looks like. Follow the path of the current. Just follow the path of the current. Redraw the circuit if you have to. Okay? Anyways, thank you for watching. Good job with this question. And good luck with the rest of your problems. Fan Mama Physics, signing out.